Hey everyone, and welcome to a new video on this channel, this time about app services for Azure Arc. If you're used to working with the Azure Cloud a bit, you probably have heard of web apps, function apps, and logic apps. Web apps allow you to run web applications and APIs. Function apps are serverless functions that are event-driven, and logic apps are workflows typically used for application integration, and you can create those workflows using a graphical designer. Well, normally those apps are created in the public cloud and they run in a location anywhere you want on the globe. Now, what if you want to run those kind of apps in your own infrastructure, in your own data center, or maybe even at other cloud providers? Well, you can with app services for Azure Arc, as long as you have a Kubernetes cluster in the location where you want to run those apps. Now, there are quite a few steps that you have to go through to enable the creation of these apps on Kubernetes. So let's quickly go through them. In a first step, you will have to link your Kubernetes cluster to the Azure cloud. You'll connect the cluster and you'll Azure Arc enable it. You'll get some agents running on that cluster, and those agents report their metadata and so on to an Azure Arc enabled resource in the Azure control plane. Now, when we want to run web apps and the other types of apps, we'll need app service prerequisites installed on the cluster. You don't have to install them yourself on the cluster, you just have to create extensions on the Azure Arc enabled cluster resource. And in this case, it's the app service extension. There are other extensions as well, such as the Azure API management extension or the Azure Event Grid extension. But this is the app service extension. When you create the extension on your Azure Arc enabled cluster resource, the app service for Azure Arc pods are installed to a namespace that you select. Now, that's not enough to deploy our apps, because the apps in the public cloud are typically deployed to a region, or they are always deployed to a region, like West Europe, for instance. Well, you need to have something similar, a location that represents your cluster. That's why there's a new type of resource called a custom location resource. The custom location is something that, of course, you name yourself. You give it a name. You associate a custom location with the Azure Arc enabled resource. And you also set a namespace. And then that namespace, in our case, would contain web apps, function apps, and logic apps, which are basically containerized versions of the web apps that you create and function apps and logic apps that you typically create with code. Now, the custom location namespace that we set here doesn't have to be the same namespace as this one, as you see here, but it can be the same namespace. So in the video, in the demo I'm going to show you, I'm going to use the same namespace for both these things. Now, having a custom location is still not enough, because you also have to have the concept of an app services environment. In the public cloud, this exists as well, if you want to have your own dedicated and isolated environment to run web apps, function apps, and logic apps. And you have to see Kubernetes as also a specialized version of that. It's your own environment to run all those types of apps. So you have to create what is called an app services Kubernetes environment, which is also linked to the custom location. And now we're ready to create web apps, function apps, and logic apps on top of this app services Kubernetes environment. Now, you don't have to specify the environment, you just have to specify the location you want the web apps and so on to be deployed. Now, normally you also need an app service plan. You can create those plans in advance and then create your apps in the plan. But on a Kubernetes cluster, that plan doesn't really make that much sense. It has to be there, right? But it's always the same plan. It's called the K1 plan, and there's not really anything specific linked to it, like specific infrastructure and so on. Maybe later that will come, but for now you just have to have such a plan. If you don't create a plan in advance and you create, for example, a function app, well, then a plan will be auto-created for you. So don't really bother too much with the app service plans. So we need to have all these kind of prerequisites fulfilled. And once that's the case, we are able to deploy these apps to custom locations. Now I'm going to show you an example with a Kubernetes cluster running on Azure. That's of course a little bit silly if you think of it, because you can of course run our web apps and so on directly on Azure. But for now you have to remember that App Services for Azure Arc is in preview, right? And you probably will find out that if you try to install this, for example, on something like Amazon, or you use a Kubernetes cluster on DigitalOcean and so on, that you might run into some issues during the preview. So during the preview, it's recommended, well, I recommend to just use AKS to, let's say, explore the features. It will work, it's tested to work, and that's something that we're gonna do in this video as well. So let's get started. The first step is to link our cluster to the Azure control plane and install the Azure Arc agents. This is my AKS cluster running on Azure, so that's great for testing the App Services extension today in the preview. And I already connected my cluster to my kubectl CLI on my local machine. But basically, I used connect and I ran the az AKS get credentials command that creates a working kubeconfig on my machine, and that is required to run this command. This is an Azure CLI command to connect this cluster to the Azure control plane. There are all kinds of prerequisites that you need to have in order for these commands to succeed. They are listed in a gist. You can find the URL to the gist in the description of this video. So I'm going to run this connect command. That will of course take a while because it has to install all the prerequisite software via Helm on the connected cluster. And what we'll see is after a while, a namespace will appear on this cluster, and that will be the Azure Arc namespace. Now, that will take some time for it to run, so I'm going to pause it and come back when it's finished. After a few minutes, you will have output, this JSON you have from the command that you ran. And if you look at the Kubernetes resources and more especially the namespaces on your cluster, you will see that there's an Azure Arc namespace. If we look at the workloads and we check the pods, we will also see that in the namespace for Azure Arc, there are several pods running. Now, the one that we are interested in here is the extension manager. This is looking for extensions we create in the Azure Arc resource, and we are going to install the App Services extension. And by the way, the Azure Arc resource I can find here in Kubernetes services. I have several here, but here I can see my Arc App SVC. That's the one that I created here in this environment variable. You can see Arc App SVC. That's our Azure Arc enabled resource in the portal. And here we're going to add later, we're going to add an extension for the prerequisites for App Services to be configured. Now we can install the App Services extension, and that's just prerequisite software for us to be able to create web apps, function apps, and logic apps. I don't have to install these components on the cluster myself. I can just use the extension model provided by Azure Arc enabled Kubernetes. So on my Azure Arc enabled Kubernetes resource, I can go to extensions, click on add, and I can simply click on the application services extension preview and then click create. That will present a wizard that will ask me several questions, and in the end, you just get a script that you have to run. Now, this script runs everything or does everything. What I want to do is break the script up into the discrete steps that you have to follow to enable everything. So I won't use the script. I will use the different paths that the script will expose to you and show you one by one how it is done. So I'm going to use the Azure CLI for this. Now I have the Azure CLI command already here in Notepad, and this is just a command which is called AZ, the Azure CLI Kubernetes extension create. This is used to create any extension, also other ones, not just app services. Of course, I need a resource group because an extension is basically a resource that you create in Azure Resource Manager. You give it the name that you choose yourself. And this extension is for an Azure Arc enabled cluster. And more low level, this is known as a connected cluster. The name of that connected cluster will be an environment variable called CLU. You see that here, CLU, and that refers to the Arc App SVC object that you see there. We're going to install the App Service extension. Release train is stable, and we're going to ask the Azure Arc agents on the cluster to automatically upgrade the extension when the minor version or the patch version changes for App Service. The team now during preview is releasing a new version every month, more or less, so then you will get these automated upgrades. Now there are some other settings as well. I'm not going to go through them all, but what you see here, the configuration settings, they are specific to this extension type. So for App Service, for example, I already have to refer to the Kubernetes environment I'm going to create later for App Service. So that's something that you have to already think about in advance. And what is also required is that the App Service extension needs some persistent storage. So it needs a storage class on your Kubernetes cluster so it can provision the correct storage for you. You can just use the kubectl command for this and then get sc to get the storage classes on your cluster. On AKS, there are several. There are file shares and there's block storage. There's also just default. And default is using Azure disks. You can, of course, choose the other ones as well. I'm going to just use default here as the storage class name. That's the command I have to run. So I'm going to copy this command here. And of course, the environment variables that are used in this command were already set beforehand. So I'm going to paste it here and then run the installation of the extension. This will take a while, so we'll pause here and I'll get back to you in a moment. Oops, it looks like I made a mistake, and of course I see it already. I see here that I made a mistake in the cluster name there. So the cluster name has a typo. I'll leave this in because that's something that happens to all of us, right? We regularly make mistakes. So this is it, and then run the command again, and then normally that should work properly. Pause here, I'll get back to you in a moment. The installation is still busy now, but I want to already point your attention to the list of extensions in the portal. As you can see here, the App Service extension that I call App Service X is already added. We are currently at version 0.12.0, but the install status is still unknown. In a while, that will change. We'll also be able then to click on the extension and see all the details as we already see them now, but the install status should of course be green here. So we'll wait a little bit further until that is the case. We are still installing, but we can already take a look on our cluster to see what is going on there. And what you should see, and I'm using K9S here to show everything to you. If you go to the namespaces, you'll see that there is now a namespace called App Service. So that is now created by the extension manager of the Azure Arc agents. When I click on App Service here, or I press enter on App Service, I see all the pods that are now busy creating. And it takes a while to provision the build service because that one also uses the block storage. So the Azure disk has to be provisioned, attached to the node, and then all that has to be wired up, and then these containers will come up. We waited long enough, and as you can see, like with the other commands, the AZ command has some output in JSON. If I look at my cluster, I see that all the pods have been provisioned properly, and I also see that the extension is now installed. It is green, everything is good to go. We can now create a custom location. And to keep track of where we are, we already connected our cluster to Azure Arc. That was the first thing that we did. We created the Azure Arc enabled resource, and we have the App Service extension. And also here, the App Service namespace was now created. To create a custom location, I do need quite some additional information. First of all, we need to associate our extension with the custom location. And we do that with the resource ID of the extension. I grab that here, and here I echo it out. This is a regular resource ID you probably know from other Azure resources. My script is using a custom location name variable for the name of my custom location. I will set it to Kubernetes home. And I also need to link up this custom location with my connected cluster. That's my Azure Arc enabled cluster. So I have to grab the connected cluster ID as well. I echo this out. This is the resource ID of our Azure Arc enabled cluster. So now we can paste this command over here, and this creates the custom location in a specific resource group. It has the custom location name. It has the resource ID of our cluster, the namespace. In this case, the namespace is the same namespace that I used for my app service pods. I use the same namespace for convenience. Okay, let's try this. Let's run this command to create the custom location. This custom location is a regular Azure Resource Manager object, and it will also appear in the list of custom locations in the portal. I will refresh it here already, but it won't be there yet. You see that I also have already another location, the Geba home location, but that location is actually attached to or enabled for the Microsoft Event Grid extension. That's another thing you can install on your Kubernetes cluster. What we are doing now is creating a custom location to another cluster, but for app services. That should now be the case. So if I refresh again, I see that I have my custom location there. And if I click on the custom location, I can indeed see that it is only for these Azure Arc enabled services. In this case, only for the app service extension. There are no resources yet because we didn't create any apps on this custom location. The next step after the custom location is the creation of an app services Kubernetes environment. To create the environment, we first need to grab the custom location ID. That's the same thing as before. It's just a resource ID, in this case for the custom location, Kubernetes home. Remember that earlier I already set my kube environment name variable to kube appenv, and we're going to use this to create the kube environment. We use AZ App Service kube create for this. Again, it's created in a resource group. It has this kube environment name, and we have to link it up to the custom location that we just created. So let me just create this kube environment and see what happens. After a few moments, we see that the command has finished and again has this JSON output with all the information. The provisioning state was still waiting at the time that I issued this command, but then after a while, we suddenly see in the resources of the custom location, we see this Kubernetes app environment that's provisioned. When we click on that app environment, there's not really that much to see. What we see is it's an app environment in our custom location, and now it has 0 service plans, 0 apps, and 0 slots. With the Kubernetes environment deployed, we can now finally create web apps, function apps, and logic apps. In this video, I will only deploy a web app. In a later video, we'll look at how to deploy a function app and logic app. I also will not focus on creating app service plans. They will be created automatically when I create my web app. So let's create a web app now. I can create the web app with the Azure CLI, but I can also create it using the normal portal experience. I'm just going to click create here, and I'm going to specify a new resource group. I'm going to call it a web app. And instead of selecting an Azure region like Central US here, I'm going to select the custom location that I just created, which, if you remember, it's tied to my Kubernetes cluster, and there's also a namespace associated with it on the cluster. So I'm selecting this, and as you can see here in the name section, we have this unique name that was generated for our app services on Kubernetes instance, and I can just type here a new name, web demo, which has to be unique within, of course, this domain suffix. Just as with regular web apps, you can select code or Docker container. I'm going to select code. I'm just going to use here Node 12 LTS, not really important for this demo. Be aware that you can only use the Linux operating system. In the UI, Windows is not grayed out, but you cannot do this. The reason is that, of course, I'm using Linux as the underlying nodes in my cluster. They should run Linux containers. Let's go to monitoring. You could associate your application with application insights. I'm not going to do that for now. Skip to tags, no tags, go to review and create, and then create the web app on this Kubernetes environment. After a few moments, the deployment is complete. We can go to the web app resource, and there we see the representation of the web app. We can see it's running on our custom location, and we have a URL that is unique for that location. There's also an app service plan, but as I said, we didn't create the app service plan. We just have an auto-generated app service plan of type K1. The web app that we just deployed will actually be running as a pod on our Kubernetes cluster. The pod starts with the name of our web app, in our case, web demo. And if you look a little bit more closely at the pod, inside the pod, you'll see that there's a container running. The first one was an init container to initialize the pod, but our actual application container is this one. It's called HTTP, and it uses, in this case, a Node 12 image because I selected the Node 12 runtime. But of course, we didn't deploy any custom code to our web app. So let's see what happens when we do that. I'm going to use the zip deploy method. I already cloned a sample repo and CD'd into the folder for that repo. And let's just zip all the files that we want to use. So I'm going to zip the entire directory that I'm in into a file called package zip. To deploy the web app from a zip file, I can just use AZ web app deployment. Note that AZ web app up does not work with app services for Kubernetes right now. I specify my resource group. That's the resource group of the web app that I created, and my web app was called web demo. This is the result of the web app deployment. Now let's take a look at the web app itself. This is the result of our deployment. It's a simple hello world application. And with that final deployment, we have come to the end of this video. The takeaway should be clear. You can use app services for Azure Arc to deploy web apps, function apps, and logic apps to any location where you have Kubernetes running. We have seen the different steps, individual steps you have to take to make sure you can deploy such apps. And we have then shown how to do a regular deployment using a zip deploy. In this case, the developer experience stays the same. Now, in a next video, we'll take a look at function apps and logic apps. So stay tuned. Thanks for watching. Bye-bye.